Okay, number 1, we have f of x is 5x to the 4/3, and we would like to find f prime of 8. This is a very straightforward power rule question. So the derivative, we bring down the power and subtract 1 from the power. And the easiest way to do that is to subtract 3 from 4, and we get 4/3 times 5x to the 1/3. We have to plug an 8 into this. So 5 times 4 is 20, so we get 20 over 3. X to the 1/3 means the cube root of x to the first, or just the cube root of x. So we need the cube root of 8, which is 2. So we get 20 over 3 times 2, which is 40 over 3. And that is choice B. So choice B is the correct answer, 40 over 3. Next question. We have the limit as x goes to infinity of 5x squared minus 3x plus 1 over 4x squared plus 2x plus 5. The quote long way is to divide each term by what's getting largest, or what's dominating the denominator, which is the x squared. That's what's getting big in the denominator. And by doing this, you can see what's significant and what's insignificant. The x squareds cancel, we get 5. 1x cancels, we get 3 over x. And as x goes to infinity, this baby fraction goes to 0. 1 over x squared also goes to 0. X squareds cancel down here, and we just get 4. 1x goes away, and 2 over x goes to 0 as x gets big. And 5 over x squared goes to 0 as x gets big. So our answer is 5 over 4. Quick shortcut method is if you have equal powers and x is going to infinity, then you can just take the ratio of the highest degree terms, which is, or the coefficients of the highest degree terms rather, which is 5 over 4. Number 3, we have a quotient. So to find the derivative, we shall use the quotient rule. So you need to identify high and low. So high here is 3x squared plus x. Low is 3x squared minus x. Derivative of the high is 6x plus 1. Derivative of the low is 6x minus 1. And so now we can put them together. The quotient rule is low d high, so I have 3x squared minus x times d high, which is 6x plus 1, minus high, 3x squared plus x times d low, which is 6x minus 1, over the original low squared, which is 3x squared minus x squared. Now that does not match the answer, so we have a lot of algebra to do here. We have, so this is f prime of x. We have a lot of algebra to do here. So we have 3x squared times 6x, which is 18x to the third, plus 3x squared minus 6x squared minus x, minus this distribution. So if we're subtracting, we need to change the signs of all the terms that we get here. So I want to remember to do that in one step. So 3x squared times 6x is negative 8, it's going to be negative 18x to the third. 3x squared times negative 1 is negative 3x squared, but remember, since we're subtracting the multiplication here, we're going to change the sign to make it a positive 3x squared. X times a 6x is normally a positive 6x squared, but since we're subtracting, it will be a negative 6x squared. And x times negative 1 is normally negative x, but since we're subtracting, it will be a positive x, all over 3x squared minus x squared. And now we have some cleaning up to do. So the 18x to the thirds will go away. The 3x squared stay, and that becomes 6x squared. The negative 6x squared, actually, you know what, we can combine all of those terms. So we have a negative 3x squared, a negative 6x squared, a negative 3x squared, a negative 6x squared. All together, that would be, I said that wrong, I'm sorry, a positive 3x squared, a negative 6x squared, a positive 3x squared, and a negative 6x squared. Negative 6 and negative 6 is negative 12. Positive 3 and positive 3 is positive 6. And so we have negative 6x squared total. Sorry about that. And the negative x and the positive x go away. So we get negative 6x squared over 3x squared minus x squared, which, if you think about what this is still not a choice. This is a tough problem. This is still not a choice, but if you think about what we have negative 6x squared over 3x squared minus x times 3x squared minus x. If you notice, on the bottom, I can factor out an x from here and be left with 3x minus 1. I can factor an x from here and be left with 3x minus 1. And so what will happen now is that this x, these x's, x times x is x squared, will cancel with this one. So we get negative 6 over 3x minus 1 squared, which is a choice. That is choice C. That is a tough problem. That's a good one, though. That's definitely a hard quotient rule problem with the algebra there at the end. And if you can get that, if you got that one right, kudos to you. That's a tough one. All right, number 4. If the function f is continuous for all real numbers and f of x is equal to x squared minus 7x plus 12 over x minus 4, when x is not equal to 4, then f of 4 is. Well, if we took a look at what f of x is, x squared minus 7x plus 12 over x minus 4, we can simplify this function a little bit. So if we factor the numerator, we would get x minus 4 times x minus 3 over x minus 4. So f of x is equal to x minus 3 if x is not equal to 4. That's because the 4 is a hole. But we want to fill the hole. If you think about a function with a hole, it's not continuous at the hole, because the hole is not filled. If we fill the hole, what we're basically saying is whatever f of x should be at that point is what we want to make f of 4. So f of 4, we want to make it 4 minus 3 to fill the hole, which is equal to 1. So choice A. Number 5, we have an implicit diff question. So we're going to take d dx on both sides here. So then we get 2x. I'm going to do a little product rule over here. I'll split this up as negative 2x and y, and taking derivatives, here we are. So we would get negative 2x dy over dx if we crisscross, minus 2y, plus, chain rule here, 6y dy over dx equals 0. So now we have all these terms on one side. I'll elect to move over the non-dy dx's to the other side. So we end up getting 6y dy dx minus 2x dy over dx is equal to 2y minus 2x. Factoring out a dy over dx, we would get 6y minus 2x equals 2y minus 2x. Dividing by 6y minus 2x, we end up getting dy over dx is equal to 2y minus 2x over 6y minus 2x. And going back to the original question, they asked us for dy over dx, and this is not a choice. Actually, no, it is a choice. That's strange. I'm surprised they didn't simplify this. Choice C is correct. We get, oh, actually, no, I'm sorry, that's wrong, because we have 2y minus 2x over 6y minus 2x, see? This is where you got to be careful. 2y minus 2x over 6y minus 2x does simplify. You can divide all the coefficients by 2, and if you do that, you would get y minus x over 3y minus x, making choice E the answer. That's better. See? You just got to be careful there. Unlike me the first time, but then I went back and kind of checked it, so that's a good thing. All right, number 6. If f of x is secant x plus cosecant x, then f prime of x is, well, the derivative of secant is secant x tan x. Yes, you have to know that. And the derivative of cosecant x is negative cosecant x cotangent x. And Voila, choice E. See, some of these questions literally take 15 seconds, and other questions are going to take you 4 minutes. All right, number 7, an equation of the line normal, important, normal. A lot of you aren't reading correctly in class. Normal to the graph of y equals square root of 3x squared plus 2x at 2, 4 is. So let's rewriting y algebraically would be 3x squared plus 2x to the 1/2. And we need to take its derivative, which we're going to use the chain rule to do. So dy over dx is, I have stuff to the 1/2, so this is derivative, that is 1/2 times the stuff to the negative 1/2 times the derivative of the stuff, which is 6x plus 2. Rewriting algebra, so this is a calculus step. Rewriting algebraically now, we get dy over dx is, big fraction. If you notice here, I have 6x plus 2, and I have 1 dividing by 2 here. So I want to take care of that pretty easily. That's going to give me 3x plus 1. And so I have 3x plus 1 on the top. And on the bottom, we have square root of 3x squared plus 2x. We need to evaluate this at the point 2, 4. The derivative is simply in terms of x, so we can plug in 2. We would get 3 times 2 plus 1 over square root of 3 times 2 squared plus 2 times 2, which is 7, over 2 squared is 4 times 3 is 12, plus 4 is 16. So we get square root of 16, we get 7 over 4. That's the slope of the tangent line. We need the slope perpendicular, so that is negative 4 over 7. So we're getting closer now. We were at the point 2, 4, so let me go back up for a minute. We're at the point 2, 4, so we want to do y minus y1. Y minus y1 equals m times x minus x1, with 2, 4 going in, and the slope of negative 4 over 7. Now, as you notice, that's on a choice. They want us to rewrite it in terms of, this is called general form, something x plus something y equals something else. So let's try to do that. We would get, if we distributed through, we would get y minus 4 is negative 4/7 x plus 8/7. Multiply everything by a 7. We'll get rid of the 7 denominator. So we get 7y minus 28 equals negative 4x plus 8. We want to get all the x's and all the y's to one side. So we're going to add 4x and add 28 to both sides. One correction I have to make. This should have been a negative sign. That makes this a negative sign. This is what happens when you do things too fast. Add 28 to both sides. And so we end up getting, let's see, 4x plus 7y equals 20. 4x plus 7y equals 20, which is choice B. And number 8. We're going to do this one, and then I'm going to stop the movie, and I'll do the rest on a different movie. So, because YouTube won't allow us to upload anything bigger than 15 minutes. So, if f of x is cosine cubed of x plus 1, then f prime of pi is. We need to really rewrite this function. It's cosine of x plus 1 in parentheses cubed. And this will help us unravel this function. We have to take the derivative using the chain rule. So f prime of x is 3 times cosine of x plus 1. So we took care, and squared. So we took care of this layer. Now we have to take care of the derivative of cosine, which is negative sine of x plus 1, times, technically, the derivative of the inside function, but it's at x plus 1. The derivative of x plus 1 happens to just be a 1. So if you forgot that part on this problem, you lucked out. But if I had like a 2x plus 1, you wouldn't be so lucky. So now we have to evaluate this at pi. So f prime of pi, I'm going to put the negative sign in front. So negative 3, because this will all be multiplied together, cosine squared of pi plus 1 times sine of pi plus 1, which is the same thing as choice A.